Hey there everybody, and how are you guys doing now? I want to welcome you to iTTV, and you are with me, Mr. Joel, your tutor for Mathematics Form 4, and welcome. Alright, in today's lesson, which is lesson 7 of our chapter 2, Quadratic Expressions and Equations, we are going to enter the second half of this chapter. Alright, if we have looked at the first part, which is called Quadratic Expressions, the second part of this chapter is called Quadratic Equations, and they are really much related to one another. Alright, now, what are quadratic equations in the first place? Identifying quadratic equations in one unknown. A quadratic equation is an algebraic equation that contains only one variable and the square of the variable, or the highest power of the variable, is 2. So it's very simple. The key word here is quadratic. And the difference between an expression and equation is the word itself. But just to check on a few things, the quadratic equation, the unknown, has the highest power of 2. And how do we further identify quadratic equations in one unknown? Very importantly, a quadratic equation must have the equal sign. The expression ax squared plus bx plus c equals to 0 is a quadratic equation. So basically, the difference between a quadratic expression and a quadratic equation is you are just going to add the equal sign to the quadratic expression that we have learned on previously. The same characteristic still applies. There must be only one unknown, and most times it is represented with x. Alright, if you put it in the general form, it will be ax squared plus bx plus c, and the highest power of the unknown, which is x, is 2. And one additional criteria is, for a quadratic equation, there must always be an equal sign. Alright, now, the highest power of the unknown is 2. For example, the equation minus 2x squared plus x equals to 9 is a quadratic equation because x is the only variable or the unknown, and the highest power of x is 2. So there can be many forms of equations, but how do you differentiate a quadratic equation from a non-quadratic equation is based on the characteristics which we have just learned just now. One variable, highest power of x is 2, and there must always be an equal sign. Alright, writing quadratic equations in the general form. The general form of a quadratic equation is ax squared plus bx plus c equals to 0, where a is not 0 and a, b, and c are integers. Alright, now, once we have identified a quadratic equation, it is important to state that quadratic equation in the general form. Why is it so? Because the quadratic equation can come in many types or many forms. To standardize every equation, there is only one way of reading it, and that is called the general form, ax squared plus bx plus c equals to 0. To write quadratic equations in the general form, let's look at this example here. Change the quadratic equation x squared equals to minus 3x plus 7 to its general form. Alright, now we have a question. And the given equation is a quadratic equation because there is one unknown, which is x, the highest power is the square, and there is an equal sign. But if you notice carefully, this equation is not in the general form. So how do you convert an equation from a regular form to a general form that we have learned just now? First step, all the algebraic terms must be written on the same side of the equal sign. So what does it mean? Shift the terms negative 3x and positive 7 to the same side as the x squared term. This means that when you have a quadratic equation, you must always shift all the terms to just one side. And which side do you go to? You always go to the side where x squared is already there. And you must leave one other side as 0. No terms belong to the other side. So once you have shifted, it becomes x squared plus 3x minus 7 equals to 0. And that is the general form of the quadratic equation. Alright, forming quadratic equations based on specific situations. Alright, let's look at this example and read together. The length of a rectangular shaped card is 4 cm longer than its breadth. If the area required is 32 centimeters square, form a quadratic equation based on the information provided. Alright guys, one of the uses of quadratic equations that it allows us to apply it to specific situations where any form of measurement remains an unknown. And when it comes to an unknown and we have x, sometimes we will get quadratic equations. So based on this specific example here, how do we go on? To obtain the quadratic equation satisfying the given condition, follow the steps below. In step 1, choose a suitable alphabet to represent an unknown if the symbol is not given. Let x be the breadth of the card. In step 2, express the other unknown in terms of the first. Therefore, the length is x plus 4 cm. And in step 3, form the quadratic equation in one unknown based on the situation. So now, remember, when there is always specific information, the most important thing is to label the equation. Alright, and if the unknown is not labeled with any alphabet, represent it with any alphabet that you want. Alright? And the most important thing, guys, is to always to sketch. Alright, if the diagram is not given. So based on the specific situation here, let's look at this diagram. The breadth is given for this rectangle and we label it as an xcm. And the length is x plus 4 cm because it is 4 centimeters longer than the breadth. So because the area of the rectangle is the length multiplied by its breadth, we can form a quadratic equation by equating the area of the rectangle, which is 32 centimeters square, and the length times the breadth of the rectangle in terms of x. So 32 equals to x plus 4 multiplied by x. So what are you doing actually? You're actually comparing the actual area of the rectangle, which is 32, and the area of the rectangle in terms of x, alright, which is x multiplied by x plus 4. Let's proceed. Expand the right hand side. It becomes x squared plus 4x. Let's move on. Shift the x squared plus 4x, or rather rearrange it on opposite sides. So x squared plus 4x equals to 32. And there is your quadratic equation. And there is one final step, which is move the 32 over to the left hand side so that you will get x squared plus 4x minus 32 equals to 0. And if you notice that expression there, it belongs to a quadratic equation in general form. So no matter what specific situation that you obtain, the quadratic equation must be written in the general form. Alright, now let's do this exercise together. State whether each of the following is a quadratic equation in one unknown. Give one reason for your answer. If it is, state the equation in general form. Alright guys, now we are going to look at three kinds of equation. we're going to go through each step and we're going to see whether each equation is a quadratic equation or not. Alright, and I would need you to come to the board with me and we're going to do this together, alright? Alright guys, now let's look at this first equation here. Alright, it is an equation. Why? Because it contains the equal sign. So in the equation, 4 over r squared equals to 3 over r minus r. Is it a quadratic equation or not? Alright, now, once you see the unknown, and if it belongs to the denominator of any fraction, you must actually get rid of the denominator. Alright, so that your expression and the equation is all in one line only without any fractions. Alright, so if you look, 4 over r squared equals to 3 over r minus r. In order to get rid of the two denominators, and one of them is the r squared and one of them is r, you must multiply every term with the highest common multiple of the denominators. Alright, and now in r squared and r, the highest common denominator will be r squared. So every term needs to be multiplied by r squared. Okay, so if 4 over r squared is multiplied by r squared, you will get 4. Alright, and we move on. If 3 over r is multiplied by r squared, you will get 3r. Alright, and if r is multiplied by r squared, you will get r cubed. Alright, so check. Multiplied by r squared, no more. You are left with 4. 3r minus r cubed. And is this a quadratic equation or not? One glance, you should know. It is not. Why? Because of the highest power of the unknown. And this has a highest power of 3, and a quadratic equation has the maximum power of 2. So this is not a quadratic equation. Alright, so the highest power of r is actually 3. Let's look at the equation B. In 5f squared equals to 3g squared minus 7fg. Is this a quadratic equation or not? Alright, let's look at this on the board. Alright, now, if you look at this, it is an equal equation, it has an equal sign. There is a square, but don't forget, because quadratic equations are very much related to quadratic expressions, and all the similarities are the same, except a quadratic equation has one extra condition, which it must have an equal sign. But for this case, it is not a quadratic equation at all. And can you tell me the reason? I'm sure you can. There are actually two unknowns. One of them is f and one of them is g. So because there are two unknowns, this is not a quadratic equation in one unknown. Alright, so let's look at the reason. It is not because there are two unknowns, which are f and g. Okay, let's look at C. In the equation, h squared over h minus 5 equals to 4h plus 3. Is this a quadratic equation or not? Alright, and let's look at one more on the board. Alright, to determine whether an equation is a quadratic equation, always try to put the equation in the general form if possible. And remember, what is the general form of a quadratic equation? Ax squared plus bx plus c equals to 0. Alright, and a quadratic equation can come in all forms, shapes and sizes. Alright, so you must do the necessary to achieve your goal of first to get that quadratic equation in the general form. Alright, so now in h squared over h minus 5 equals to 4h plus 3, there is a fraction. Fractions are no good for quadratic equations, alright? So get rid of fractions. Alright, and how do we get rid of h minus 5 in this question? We cross multiply the terms. So h squared is equals to 4h plus 3 multiplied by h minus 5. And now try to expand on the equation on the right hand side. Remember, no brackets because we want terms by itself. So expand slowly. And try to simplify the equation. Follow me. 4h squared and minus 20h plus 3h gives you a minus 17h and minus 15. So this is the quadratic equation, but try. If it is, we always want to get it in the general form, which is to get all terms to one side and leave the other side with nothing. Okay, so always the bigger constant of the square must always be written on the left hand side. And finally, h squared must be brought over to the left hand side. So what will you obtain? 4h squared minus 17h minus 15 minus h squared, don't forget, equals to 0. And 4h squared can subtract h squared. So you will get 3h squared minus 17h minus 15 equals to 0. And guys, is this a quadratic equation? One look, let's check. Oh yes, it is. There is only one unknown, h, and the highest power of h is 2, and this whole equation has an equal sign, and it resembles the general form of a quadratic equation, which is ax squared plus bx plus c. So bravo, you have got one right there. So let's look at the answer. Yes, it is. The highest power of h is 2, and the general form is in the bracket, which is 3h squared minus 17h minus 15 equals to 0. Alright, let's look at the, and we don't have to go to the board for this. 6k squared minus 10k equals to 3 over 8. Is this a quadratic equation or not? Alright, the answer is yes. The highest power of k, which is the unknown, is 2, and this whole quadratic equation can be put into a general form of 48k squared minus 80k minus 3 equals to 0. Alright, now let's look at an exercise that is based on a specific situation. Alright, come. In number 2, a closed cuboid has a width of 6 cm, shorter, and a length 3 centimeters longer than its height. The total surface area is 200 centimeters. Obtain a quadratic equation satisfying the given information. So guys, we have here a specific situation. There's a cuboid, there are some measurements, but it's all here and there. So remember, what must you do? First, when you're given a problem, get a representation for the unknown. And secondly, sketch, alright, if the diagram is not given. Alright, so now, after sketching, we have a cuboid here with the height is hcm from the given situation, and the length is 3 cm longer, so that makes it h plus 3, and the width is 6 cm shorter than the height, which makes it h minus 6 centimeters. Alright, now, based from the given information, the total surface area is 200. So now, what is the total surface area? Since a cuboid has 6 surfaces, you must actually add the separate surfaces and equate it to 200. So once we do that, the total surface area is 2h by h minus 6 plus 2 of h plus 3 and h minus 6 plus 2h by h plus 3 equals to 200. Expand the expression on the left carefully, equate it to 200 and bring it over to a general form. So the answer is 3h squared minus 6h minus 118 equals to 0. Alright guys, enough of me talking now. Why don't you try some? Alright, that brings us to our quick test segment for today. I want you now to complete the table below. Okay, and for question 2, the square of the sum of two consecutive positive integers is 113. Form a quadratic equation based on the given information. Alright, first thing first, the table in question 1 is here. Alright, this table, you will be given quadratic equations. Alright, and you must state whether it is or not a quadratic equation, give a reason, and if it is a quadratic equation, put it in the general form. Alright, so that is A, m square equals to 3m, and B, p square minus 3p plus 3, and C, t equals to 3 over t minus 5, and D, s square equals to 4 over s minus 3. Alright, now I'll be giving you some time and we'll be back again to discuss this shortly. Alright guys, I'm sure you have your solution with you and now it's time to go through one by one, right? Alright, for A, the algebraic equation m square equals to 3m. Yes or no? Is it a quadratic equation? Yes. If you put that, congrats to you. What is the reason? One unknown of highest power 2. So m, there's only one unknown and it is a square. So it is. So one it is, one final step, shift it to make it general form. So remember, you're always bringing any other term to the side where the term has m with the square. So it becomes m square minus 3m equals to 0. In B, p square minus 3p plus 3, is it a quadratic equation? Obviously not. Why? Because it is a quadratic expression. Everything follows except there is no equal sign. So we are learning quadratic equations today, not expressions. So this is not a quadratic equation. In C, t equals to 3 over t minus 5. Yes, correct. It is a quadratic equation because this can be converted into a quadratic equation. And how do you do that? Alright, based on the example just now on the board, the same method. Get it into general form and rearrange it. And the general form is t square minus 5t minus 3 equals to 0. And in D, s square equals to 4 over s minus 3. It is not a quadratic equation. Why? Because the reason, it is a cubic equation of one unknown where the highest power is 3. So when you multiply everything with s in this equation, the highest power of s will be 3 instead of 2. It is not a quadratic equation. Instead, it is called a cubic equation. And for questions like this, don't change it because there is no general form. Alright, and for question 2, early on, here are the steps of the solution. Step 1, let the smaller integer be n. And in step 2, therefore, the greater consecutive integer is n plus 1. In step 3, make an equation based on the given information. So, n square plus n plus 1 bracket square equals to 113. Expand the bracket. N square plus 2n plus 1 equals to 113, and shift it to get a quadratic equation in general form, which is 2n square plus 2n minus 112 equals to 0. So guys, we have now come to the conclusion of lesson 7 of chapter 2, and let's review what we have learned today. We have learned about quadratic equations. And don't forget, it is different from quadratic expressions because of the equal sign. Everything else is the same. And once a quadratic equation is identified, find a way to convert it into general form because it allows you to proceed to further operations involving quadratic equations. Alright, and finally, when you are given a specific situation or condition, and you are required to form a quadratic equation, draw a diagram and label the equation alright, and the unknown as x if it is not given. Alright guys, we are done with lesson 7. Remember guys, practice makes perfect. And I'm sure if you practice, you'll be able to get it in no time. Alright, done for now. We'll see you in the next lesson. Goodbye.